Number 4, we'll see if this one comes out any better. Now this one's going to be a percent mixture problem, but going to look pretty close to what we just did on the previous ones, but this time we're going to use some percents. So we want to think about that if I take the percent times the amount, I get the pure substance in there. It says a petroleum company has 2 different sources of crude oil. The first source provides crude oil that is 50% hydrocarbons. The second one provides crude oil that is 75% hydrocarbons. In order to obtain 120 gallons of crude oil that is 65%, how many gallons of crude oil must be used from each of the 2 sources? So I want to think about, if I have a table here, that if I take the percent times the amount, it's equal to the pure substance that I have. The first one is 50%. The second one is 75%. And I want to get 120 gallons of a crude oil that is 65%. So if I add my total, I'm going to have 65% that is 120 gallons. So I don't know how much of A I have, I don't know how much of B I have, but if I take 50% of A and 75% of B, I'm going to get 65% of my 120. What's 65% of 120? If you take 0.65 times 120, I'm going to get 78. So when I do my 2 equations, one of my equations is usually going to come from adding the amounts together. One of my equations is going to come from adding the pure substance together. So one of my equations is just that A plus B equaled the 120. Whatever we had of A plus whatever we had of B made the 120 that we had all together. My other equation comes from my percents. 50% of A plus 75% of B is going to equal my 65% of 120, which we said was the 78. And so again, we can solve by either addition or substitution. I like the addition method better. So I'd probably just take my top equation times negative 0.5 so that we can eliminate the A's there. So negative 0.5 times A would be negative 0.5A. Negative 0.5 times B would be negative 0.5B. And then if we take negative 0.5 times 120, we get something like negative 60, right? 0.5 is half of 120, 60. So now I can add my equations together. I have opposites in front of my A's. They're going to cancel out. 75% minus 50% would be 25%, 0.25B. 78 minus 60 would be 18. And so in order to solve that, we're going to divide by 0.25. So if you take your calculator and take 18 divided by 0.25, you get 72. 72 would make some sense. So we know we had 72 gallons of B. We want to also know how much we have of A. Well, again, we knew that the total was 120. So if we take A plus 72, we get 120. And all we really need to do is subtract then. What was that?
48.
48. So A is going to equal 48 gallons. So we have 48 gallons of A and 72 gallons of B. So, the Royal Fruit Company produces 2 types of fruit drinks. The first type is 40% pure fruit juice. The second type is 90% pure fruit juice. The company is attempting to produce a fruit juice that contains 75% pure fruit juice. How many pints of each of the two existing types of drink must be used to make 150 pints of a mixture that is 75% pure fruit juice? So our two types, Tropic Tangy and Berry Good. I'm going to use T for that one and B for that one just for fun. Tropic Tangy, Berry Good. So our first equation coming from our amounts. You can make a table if you want to make a table. I don't know that you really need to. But if I look at my amounts, the sum of my two amounts is going to be?
So T plus B equals 150?
Exactly. The amount of T plus the amount of B is going to be equal to 150 pints that we had all together. Then doing our equation from our percentages, we're going to have what?
Okay, 0.40 T.
0.40 T, or you could just use 0.4. It's the same thing as 0.40.
Wait, plus 0.75 B equals 150, right?
No?
No, equals, I don't know.
How did we get that N number before? How did we get the 78, I think it was, on the previous problem? We have 150 pints, that is 75% juice. So we have to figure out what is 75% of 150. So 75 times, or 0.75 times 150 is 112.5. So this is going to be 112.5 because it's the amount of pure juice that we have. The rest is probably water and sugar and some other additives. So if we want to solve this by the addition method, we're going to take our top equation times negative 0.40 so that we can make opposites. I don't know why I write that line there because I'm going to have to do my adding to that. So, multiplying that out, negative 0.40 T, negative 0.40 B equals, what's negative 0.40 times 150? Negative 60. Adding our equations together, the T's are going to cancel out. 75% minus 40% is 35.35 B, right? 35% of B. 112.5 minus 60.
52.5.
52.5. So in order to solve that, we're going to divide by the 0.35.
150.
150. 115?
150.
It came out to 150. 52.5 divided by 0.35. That means we have none of the other one. Oh, wait a minute. No. Never mind, we have our equations wrong. I better pay a bit more attention. We could have 0, but we won't. Because this number right here wasn't supposed to be 75%. How much, what percent was type B?
Oh, crap. 0.90.
90. That's why that's not working out right. It's always good to look at your answers to see if they make sense. Now we get to try that again. Gosh, it must be Monday today. So, bottom equation should have been 40% of T, 90% of B equals 112.5. And then we can still multiply by our negative 0.40. So negative 0.40 T minus 0.40 B equals, what was that, negative 60? Is that what that number was?
What?
Negative 40 times
Yeah.
150? All right. So when we add, 90% minus 40% is going to be 50% of B. 112.5 minus 60 was 52.5.
Yeah.
Now if we divide by our 0.50, B equals 105. I didn't think the full amount was going to be all 150. We know that the sum of our two was 150, right? So T plus 105 equals 150. How much does that leave for the tangy tropic tangy?
55.
How about 45?
Oh, yeah.
So 45 pints of tropic tangy and 105 pints of very good. All right, number 6, same kind of thing. A chef is using a mixture of 2 brands of Italian dressing. The first brand contains 6% vinegar. The second brand contains 10% vinegar. The chef wants to make 320 milliliters of a dressing that is 7% vinegar. How much of each brand should we use? How much? So, our first equation is going to be
F plus S equals 320.
F plus S equals the 320 milliliters we had all together, right? Our second equation, using our percentages, we're going to have what?
0.06 F
6% on the first plus
0.1 S
0.1 or 0.10 S, whichever way you want to write it, 10%, equals, how do we get that in number? This is day 21 on the chapter 3 packet. Yeah, chapter 4 one. So there's another packet over there. What did we do to find that n number on our second equation?
$2.24.
224. How'd you get 224?
Times the 320 by 0.7.
320 times, not 0.7, because that'd be 70%.
Wait. 0.07.
0.07.
Okay, hold on. Let me do that.
Okay? Right, we got to take our amount times our percent.
22.4.
So 22.4. The 7% is not very much, right? I did that again. I keep wanting to draw a line underneath there. I don't want my line underneath there. So if I want to get rid of my F's, I'm going to multiply the top equation times,
6%.
or
0.06.
negative, right?
Yeah.
0.6%. Negative 6%, so that I have opposites in front of my F's. So what's my new equation going to be?
Negative 0 or 0.06 F plus 0.0 negative 0.6 S equals
What was that? Negative 19.2? So 6%, or negative 6% times F, negative 6% times S, negative 6% times my 320, which is negative 19.2. So when we add our equations together, the F's cancel out. 10% minus 6% is
4%.
4%, so 0.04 S. 22.4 minus 19.2.
3.2.
3.2, and then we end up having to divide.
80.
S equals 80. S equals 80. So we had 80 milliliters of our second one. How are we going to find out how much of the first one we had? we're gonna say that F plus 80 equals the 320 total, right? The first one plus the second was 320. We know the second one is 80. So if we subtract 80 from 320, 240, we have 240 milliliters of the first one.
What was the top one?
240?
And then the very